Did it work? Okay, got it. Hi, how are you? You're not coming through for some reason. Um, Maybe I've got the wrong. Let me see where my audio is to.
No, I hear you fine.
Okay, okay. Your video is not moving or anything.
Well, I thought I'd save on bandwidth because I didn't have anything to show you. You want to
Oh,
see
okay.
me? You're the one
But
who's showing.
you can see me.
Yeah, yeah,
Okay,
I see you fine.
okay. Let me turn off that music. This is good. At least we got connected.
Oh, yeah. Yeah, then the
Um,
next step will be sharing windows or something like, oh, recording. So are you recording?
no, I'm not recording.
Mine says I'm recording, so I guess I'm recording. Yeah.
Yeah, yeah, it said recording in progress. You don't really need to record anything, I don't think,
Well,
unless you
you
want
wanted
to.
you wanted to test.
Okay. Uh, uh, what you had written a letter on the how you wanted to present this.
Um,
What's the best method for presenting what I need to present?
Well, I can't remember that letter. What I was thinking of last night is I could start a space on Quora, and if you want to, it's optional because you'd have to pay for it, would be advertising to bring in more traffic. I'm doing that with a space I started on Quora, a contest, a challenge, a 100 watt light bulb challenge, and I'm limited in funds, so I have to do the minimum expenditure of $5 a day. Um,
Right. Is there a on your deal where it doesn't cost anything to advertise to do this?
Well, it doesn't cost anything to start a space.
Right.
So,
Okay, let's do that. Let's not because if it doesn't go anywhere that
right.
way, then there's no reason to spend money for nothing.
Yeah, that's true. Yeah, mostly
Yeah,
I think all my ad is doing is getting visibility, and I figure that's a gain because at least I want to plant the seed in people's brains, even though, it's not going anywhere.
right. Well, that's the way this seems like it is. I send out these emails to people, and there's really no feedback at all.
Well,
Uh,
I didn't, I have to admit, when you came to me, I was clueless over what you were doing because I don't have any experience in simulating it, and I certainly don't have any experience in building magnetic style circuitry.
right.
Last night, looking over it, I managed to find some correlations or similarities in converting certain parts of your diagram. See, the other diagrams you showed me, I can't make any sense out of them, but the one you sent me recently, the assembly drawing, makes sense because it's simply how to put it together, and the parts, maybe it's different than the other diagrams you sent me over about a year ago, but it makes sense to me, so that at least I can partly understand what's going on and appreciate what's happening. But it's hard for me, so you got to bear with me because I don't have anything to refer to, and I think that's the problem with most people when they look at our stuff. They don't have anything to refer to.
Right. Well, I've got the motor here. Um, there's the motor.
Now that's
Let me do
exactly the way your assembly drawing says you built it, other than the
this.
shielding.
This is, let me see. So that's a coil right there. Let me get some more light on it.
But I mean, it's got two copper plates and a coil
There's
and the
well,
bolt.
here's a coil here. Let me get it a little higher so it's a little easier to see. Hopefully my computer doesn't fall on the floor. Okay, so can you see that?
Well, sure, I can see it like before.
Okay, so basically, here's a coil here, and then there's another coil on the other side. There's two coils.
Oh, so that
And
drawing only pertained to that coil.
only pertains to this coil of how to assemble
Oh.
just this coil.
Okay.
The motor, I got drawings for the motor too, but I didn't send that.
Well,
just
you sent me drawings like 8 or 9 months ago that were
but probably not of this motor. This was
okay.
built in it was built and tested in December 22.
Right,
So
yeah,
this is
that's when you sent me drawings.
okay.
And also in the spring of was it, oh, wasn't it the spring of last year and then December of last year?
Could be.
Yeah.
Could be. So so anyway, what this motor does is it's just basically an induction motor. So it's just basically it draws it into iron. So this spins like this, pulls it in to an iron plate. Let me see if I can show that.
So you don't power this, it just spins on
I do, I power it.
Oh.
So it basically it runs on 35 watts, and I'm using the friction of the bearings to calculate how much power it actually produces. So what I do is I did a pull test on this shaft here, and I could calculate that it takes about 0.32 foot. Well, let's see that. Yeah, 32 pounds per foot of travel. So if it travels at a certain speed, a certain RPM, it'll produce a certain amount of watts. It takes a certain amount of watts to produce that. So let me just turn it on for a second. It's kind of neat to watch.
Do you have
So it runs on this power supply here, and
are you making contact with the motor using you scraping two wires across the
yes,
top?
there's brushes here. There's brushes on both sides and a commutator on the wheel. This will all be shown later. I'll show you all this in in drawings later. We just want to this is basically just for a show and tell thing.
How much boost do you get with that magnetic shielding covering half the diameter or circumference?
What's that?
How much boost do you get with that shielding covering half the circumference?
I'll have to ask that again after it stops.
Oh, it's making noise? I don't hear any noise.
Right now it's running 641 RPMs.
Okay.
And it's running on about 85 watts, maybe 90 watts. Okay, so right now it's running on 90 watts. It's running at 686. I'm going to turn it off. Okay.
Yeah, I'm curious what those bolts are surrounding the circumference.
What's that?
The bolts, are those positions for future coils if you wanted to put on more coils?
Yes, yes. But what it was is this was I already had this the centerpiece for another motor. And there's 22 of those bolt, so they don't really line up to do any more. If you're going to do, yeah, it doesn't really work for anything. I have to make a new
oh, they're too closely spaced to put another
too
coil?
closely spaced, right?
Ah.
So I just make another hub if I was wanting to do motor. Anyway, so the that was running on about 90 watts, and the running at 680 RPM. I'm going to do the calculation on that real quick. That's 0.32 times 680 divided by 550 times 746. That was producing 295 watts just then.
Not bad. So
running on 90 watts to produce 295.
That's 3 to 1. That's not bad.
Yeah, 3.228 to 1.
Uh-huh. So
yeah,
you put energy in to get it started, and then you've got a mechanical energy, and then you've got electrical energy keeping it running.
Well, the electrical energy part is just basically energizing the magnet that's there to a greater point. So, but the electrical energy is not pushing the motor. It's the permanent magnet that's actually pushing the motor.
So you mean you're using electrical energy to what do you call
enhance
it?
The magnetic,
enhance.
The permanent magnet.
So basically, without it, it'll still run?
Oh yeah, well without the electrical part, no, because the magnetic energy that's there, the permanent magnet energy only, is only as much as a normal coil would be. But the other side is also on, so there's as much input as output. It's even. When it's off, it's even.
Oh.
But when it's on, one coil is on 4 times, and then the other one is off. So a regular coil produces 1. When you energize this type of coil, you get 4, and then the other side is actually reversed and turns off. So you got input of 4, output of 0. You know, if you were, and basically, so it's like if you were having the magnet going to iron, it would stick, and then you turn it off and release. Turn it on, sticks. Turn it off and release. But it's going in a circular, so you have 2 magnets. One is being pulled in at 4 times. The other one is turned off, not, giving no back EMF. This has full EMF 4 times. This has 0.
Okay, so
between the 2 coils, you have this each coil was running on 45 watts, so it's 90 watts total.
So you're still getting a gain even with the electrical power off, because I mean, in terms of what convention dictates. If it's even, Steven, in versus out.
Yes.
So that's still pretty good.
Yes.
Wow.
No, it's a neat system. I mean, it's what I was originally trying to do was to just turn the magnet off, just turn the permanent magnet off using the coil. But then when I energized it the other way and got that much power output, it's like, oh wow, okay, it changes the whole thing.
Do you have any it'd be nice if you had a video that you recorded of constructing it, so that a viewer could see where all the parts go, or I
have a breakdown photographs of the whole thing.
Oh, okay, so it could be a
I'll send that to you.
Then all right, we can make a slideshow out of it. Yeah, because I'm curious what the internal structure of the thing is, but okay, so that'll be.
I will after this, I will get a whole package of those things together and send to you.
Okay.
So basically, the design works very simply. It's just there's only 2 magnets on at a time. If you had 20 magnets on, you'd still only have 2 at a time. You'd have one that's full power and one that's off. But being so, the watts would never be over 90 on this thing. But because of the constant the constant draw into the induction field, the output would be like 2,000 watts, something like that, for 90 watts in. That 90 watts doesn't change. On this particular one, because there's so much distance between the magnets, you have only two magnets running. If you had all the magnets around there, it would be like every time the magnet came into the position to be on, you would have torque. You see what I'm saying there?
Barely. Well,
It's yeah, it's okay. Don't worry about it.
well, no,
There's a lot to explain. That's part of what this is all about, is getting all this explanation down so everybody understands it. Because it is a little bit hard to wrap your mind around the first time.
Let me take a guess then. If you had more coils, then the ones that are not engaged at any particular time, they're not as if they're not there because they've got reactive power stored in them, right?
Yes. If they're not on, they're not doing anything, but they're not drawing anything either.
But they're pre-energized with reactive power, so it's not like they're useless when they're there. They're serving.
Well, they're only useful in that time frame in which they're being drawn into the induction.
I see. So no, the gain would be having them is that you don't have to wait as long because you're losing.
Exactly. You don't have the percentage is 360 rather than just 2. It's like if you had 2 gears turning, and this gear here produced 1 horsepower, the exchange of that 1 horsepower is only on the 1 gear. But if you have a multitude of gears, there's always being exchanged of that 1 horsepower, and that's kind of how this acts. It's acting like a gear, a single gear that's being turned. And on the other side, there's no there's no back resistance because it's off. And this one here has full power to push.
So now it's stimulating an idea, a suggestion, a scenario. What if you only have 1 coil that you have to use because you're only using 1 coil, right, at a time? So you only need 1 coil.
You still have to turn the coil on, and then you have to turn it off when it goes out. It's like if you're
so 2 coils.
Whatever goes down has to go back up.
Okay, so
going back up, it has no weight.
All right, so
going down, it has 4 times the weight. Going back up, it has 0.
Oh, so you're relating that to gravity then?
But yeah, well, in this point, yes.
Okay, so if 2 coils are the minimum, but you gain advantage by having more positions.
Yes, and it doesn't draw any more amps. I mean, any more watts by doing that.
No, it wouldn't. You're right, because you only need 2 coils to operate it. So
yes,
what if it could be possible? I don't know if it's possible, but what if it could be possible if kind of similar to bouncing light around using mirrors, you go around one of these scopes you use when you're a kid to look over the edge of a wall.
Periscope.
Yeah, a periscope. So you've got these mirrors reflecting. So what if you had the coils in a different position, more closer to the axis, and you could shuttle the magnetic force from those coils down and then out the position you want to when you want it, kind of like a commutator situation.
Right. Well, there's millions of different possibilities using this technology. So yes, that could be one of those.
So then you could put in as many of these ghost or whatever coil magnetic shootings that you would want to get the extra gain and still only have 2 coils. And so you wouldn't be limited by your dimensions, the construction. You could have as many as you want.
Well, instead of turning the coils, you had a multitude of induction fields.
Yeah.
So the coils would be single, and the rotor the field would be rotating with a multitude of fields. Yes, right. I thought of that too.
Okay. Wow.
And actually, that increases if you was to use both coil and that, the horsepower would increase incredible.
Yeah, of course, you'd get so much out of it. Yeah.
Yes. But the thing is that the coils, if they're not being shut off, they heat up. You know how a regular coil that's just, if you just have a magnet hooked up to a battery, it just heats up.
Yeah.
So if you don't shut them off for a duration of time, they will heat up. The other way to do this is just have them water cooled. Tesla did that with his motor. He water cooled it.
Right. Okay.
And I thought of that too. But yeah, there's lots of ways to get lots of horsepower out of this.
Oh, okay.
And you still, and the best part about this is that you're only putting in 1/4 of the watts that you get out, at the minimum.
Say that again.
I mean, the maximum, the percentage, the rate for the maximum could be 1,000 to 1. Input to output.
Okay, but you lost me on the quarter.
Oh, when you put the watts to a single coil, it puts out 4 times more energy than a normal coil.
Oh, this specific design. I see.
This specific design, right? Any coil will do that. I mean, any one, it doesn't make any difference how small or how big the coils are. They basically put out 4 to 1 to a normal coil.
Oh, yeah, that design of that coil intrigued me. Is there I can't remember. Oh, yeah, so the similarities intrigues me because it looks similar to what I've been dealing with recently. The 2 copper discs are basically low inductance coils. They're a single loop of wire with a fairly good gauge.
Right. But those particular items are just to hold the wire from escaping.
Well, but have you tried plastic versus copper to see if there's a difference?
No, I wasn't interested. I figured the copper would be fine. But I'm using it for strength also because this thing is actually turning and producing torque, trying to push the copper coil, off the coils.
Well, I think it's contributing, and of course the magnet.
Well, it could be.
The magnet, I think, is to me, the permanent magnet is analogous to a full diode bridge feeding a capacitor because it's forcing a DC situation that's kind of static. It just builds up power and then holds it. I mean, does that sound?
I don't know. I don't know if the discs are doing that or not. I haven't done that experiment to
because
see.
If it would be, what that would imply is that you've got voltage stored in the coil that never is spent. You're just borrowing the voltage, but you're not spending it.
Yeah, that's sort of like what's happening, yes.
And which is what simulators trained me to do is to think about voltage and current as separate issues, and you got to deal with them separately, and you can't just deal with them together. So I would deal with the voltage as a borrowing condition and then get my current elsewhere because I knew I would have to spend it. So it looks like that's what you're doing. You're dividing the various tasks so that you can get the overunity that you want. Otherwise, people don't know that overunity is slightly complicated. It's not like rocket science, but it's not.
Right. This is really not overunity because it's using only the energy in the magnet, which is not going over what it is. It's actually unity but using a permanent magnet source as the unity.
Well, yeah, if you're only considering the permanent magnet, but you've also got the electric power to consider.
Right, but I don't want to call this overunity at all. I'd rather keep away from that.
No, I don't blame you. Some guys are,
Yes, I don't want to call this. That's why I changed it to EttCM.
Oh yeah,
to get away from perpetual motion and overunity.
So what does that acronym represent?
Energy to torque conversion motor.
Oh, okay. Yeah, what was it? I forget the guy's name. He was down in New Zealand, I think, who did a magnet motor, and he shied away from overunity as well.
Yeah, well, these aren't overunity motors. If you're taking the permanent magnet and using it as a propellant, you're using it as just like it would be a fuel. It's not creating more power than it has.
Well, it's not exact. Yeah, it's fuel, but you're not spending it. That's the advantage.
Right. But yeah, it's not going away, but you're also not creating more than it is.
Okay, so you just reuse it, and that in itself is a humongous advantage right there.
Oh yeah. Well, it's like the sun. It's not going anywhere.
Yeah, Jim Murray and Paul Babcock, they managed to put their two heads together to create a condition in which they reused reactive power so efficiently that they got something like 1,000 to 1 gain. That they claimed if everybody did this in their home meter or on their side of the meter, they were quoting Jim Murray was quoting Tesla. I don't know, I never heard of this before, but if everybody had their system, and it was a switching system involving switches and capacitors, bouncing the reactive power back and forth in-house to get 1,000 to 1 gain, because they were reusing the reactive power over and over again. So I guess if you had inductive loads in your home, there'd be an advantage.
Right, right. But you'd have to have it set up to do that.
So it's yeah, they ran a demonstration. I went to the conference where they had the demonstration, and they were lighting a light bulb with a certain gain. I can't remember how much. It wasn't that much, but they were drawing power from the outlet on the wall outlet, and they got a gain out of it simply because they were reusing the reactive power. So if you have a permanent magnet and you're reusing it, that's a gain already.
Yes, but I still want to keep away from overunity.
No, that's fine. Oh, I know. People turn off with the minute they hear that. They don't want to read any further or listen further.
Right. Well, like I said, what this is doing is this is taking the charge of a permanent magnet and just basically using that power. It doesn't make any difference how long it lasts, but you're still only using that amount of power.
But well, would you want to go so far as to say that you're reusing that power?
No, you're just using it. You're not reusing it. You're just using it. What I think a magnet is a centrifugal force. Once you get it started, it just keeps going like gravity. That's why I also have another term called magnegravity.
Oh, so now how do you relate magnetism to gravity? Or is that
they both run for a very long time and don't use any power to do so?
Yeah, okay.
Actually, both gravity and magnetic are not energy. They're not considered energy. They are considered force. The energy is what the magnets do. They take the iron and they get it moving. That's energy.
Is that magnetomotive force?
Well, it's like in gravity, gravity itself is not energy, but the water that it takes when water starts moving, that's kinetic energy. So what it is the water is potential energy. Once it becomes moving, then it's kinetic energy. But the gravity itself is not energy. It creates the energy.
Okay, I can appreciate that. Is the magnetic force magnetomotive force? Is that what that is?
Magneto force is you have to have power to run the magneto to get the power out.
Oh, you mean an electromagnet?
Right. Well, magneto is basically just a magnet running over a coil. That's a magneto.
Isn't that what you have here?
No.
Don't you have magnets on the shield? Is that what you have on the shield? 2 magnets?
I got magnets on the shield, but they're balancers.
What
they're just to balance the load.
What does that mean? What I don't understand.
Oh, well, I have the output isn't exactly correct because it's overpowered slightly. So I had to reverse it slightly to get it to not be pulled back in on the counter reaction side. The action side is the 4 times, the counter reaction side would be 0. But because I've overpowered the coil slightly, it wanted to be drawn back into the magnet because it actually went past reverse. It went past 0. It turned the magnet off and then turned the electromagnet on slightly to make it the electromagnet part draw back in. So they're just balance. If you was running it perfect, the input would be 4 times and the output would be 0. I'll show that on a drawing that I send you.
So you're not using the magnets as braking magnets, are you?
No.
Oh, some kind of
these are you talking about the ones? Are you talking about these magnets here on the side?
Yeah, yeah, they're sticking out there.
Yes, those are just balance. They're just for balancing the input output. mechanism. See, when this magnet goes in here, this one here goes in, it's on. That's full power. When this one here comes out, it should be 0, but because I overpowered it slightly because I didn't have the correct voltage to use, it actually reversed and tried to draw backward. It was actually operating backwards. So I put a little balance magnet here pushing against it on the way out.
So that it smooths out the rotation.
It smooths it out, right?
I'm getting.
And I
Go ahead.
did that by just checking the speed output and just adjusting them a little bit backward and forward to get the highest RPM.
I've got a notice here telling me to pay the money if I want to go over. I've got 10 minutes left remaining. I'm limited to 30 or 40 minutes, I think.
Right, I got that same thing. This is fine. This was just a test meeting, so
Okay.
and we covered a lot. This is good.
Yeah. What else can be said about it? Because I don't know enough to ask questions, really.
Right. Well, I'm also talking. You know, George Wiseman of Eagle Research.
No.
Okay, I'm talking. He's from New York. He's got it also. He's also worked in this for many years. He does different things. He does Brown's gas generators and things like that. Anyway, I've been talking to him, and he's also confused. But yeah, so he's asking me questions so I can come up with answers.
Uh-huh.
So I'm working with you and him. He also has a large audience that he communicates with.
I think it would help me if I built it, but how much do you know what your expense was in building this particular unit?
Well, I build things myself, so and I get a lot of parts for free. So the only expense I had really was the wire and the magnet. Everything else I had. So probably I spent $200 max.
Oh, but it would be more if I had to get everything from scratch.
Yes, yes. But I have my own shop. I have my own fab shop in my yard, which is a 40 by 70, which I have everything. I have shears and welders and rollers and everything.
Oh.
Yeah, I've got a total fab shop. I set myself up in life to do this. This is my goal project.
I see. Okay.
I'm not going to manufacture these things. I'm just a researcher.
Yeah. Yeah, that would help, I think, in understanding if I had a working model that I had to put together myself, you know.
Yeah, that's difficult if you don't have a fab shop.
Well, expensive if you have somebody, if you outsource it.
Yeah, oh yeah, definitely. I mean, if I was to outsource, this would probably be $5,000.
Oh, okay. That's good to know.
Yeah. Yeah, outsourcing is really expensive.
There's no way to further scale this down to a toy size that would be cheaper?
Yeah, you could, but this is what I had just to work with, so I did this.
All right.
And I had another guy in Australia, which was he was a SolidWorks engineer, and for some reason he just lost contact with me. I haven't been able to contact him, so I don't know what's happening there. I actually sent him everything to develop a SolidWorks simulator.
I don't know. What does that mean, SolidWorks?
Well, SolidWorks is a program that you can put in all of the components and it'll work in real time.
Oh, the materials of construction.
Yes, yes. So you can do all computer animation of this thing, but it's not just animation. It's actually does, you can put in all the magnetic field intensities and all the inductions and everything, and it'll actually run in real time and tell you exactly what's happening. And you can change the components to whatever you want without actually having to build the thing.
So that's the name of the product. Do you know the name of the company?
SolidWorks, if you just look it up, but it's a very expensive program.
Well, I'm sure ANSYS has something similar, I think, and yeah,
there's several different ones. Yes.
Okay. Yeah, I kind of dream or wish I could do something like that because I'm using such simple stuff. I really don't know what I'm dealing with ultimately.
do you have the capability of making a small magnet and a small electromagnet
Um,
and
well, I
putting a
don't
magnet
know.
on the back of it? What's
Um,
that?
what's entailed in making a little electromagnet?
Well, you got the drawing. I sent you that drawing of it.
Okay. Let me go take another look at that.
We only have about a minute left, I
Oh, on
think,
your side, really?
on your side,
I
according to what you were
see, I
saying. We've
see
only just
four
got.
minutes. I see 4 minutes.
Oh, okay. 4 minutes remaining. Yep. My vision was blurry.
Uh,
Anyway, so yeah, if you had a even getting a coil and putting a magnet on the back and putting voltage on it, you can see what the difference between the not having the magnet and putting a magnet on the back. It doesn't really make any difference what size or anything. It's just
I do have coils that somebody sent me, but their core is powdered iron compressed.
that's fine.
Yeah, they've got two windings on them, solid copper core. I could
Yeah, just stick a permanent magnet on the back. See what it pulls. Just take a piece of metal and stick to it and see what it pulls when it's on. Don't use a lot of watts, and then put a magnet on the back, and then stick it, and then pull it off, and then turn it on and stick it and pull it off, and see what you got. You'll be amazed.
Does it matter whether I put it on the end or on the side?
The end it has to be on the end. It
Oh,
has to go through it.
oh, okay.
If
All
you
right,
put
I'll
it on
try
the
that.
side, you get nothing.
Yeah, I've energized them with a 9-volt battery.
Yes, that would be fine.
Okay. Yeah, I was doing PMH experiments to see if the core was appropriate, and that's when I realized it was not appropriate for a perpetual motion holder. Edward Lee Scullin, it had no remnants to the core. So that's when I realized it was probably a
Well,
powdered core.
yeah, those powdered compressed were used in telephones actually.
Okay. For a certain reason, I guess, having to do with.
Well, they did not hold a magnetic charge.
Right. But why do you want that in a telephone line?
Well, because you don't want you'll get a better
Oh,
sound effect if they don't
that's
stick to
true.
they
That's
have to
right.
vibrate.
That's true. Yeah. So that would be high frequency. Yeah. Okay.
Yes, well, just your voice frequency anyway.
Yeah. Yeah. That's high enough. Okay. Yeah, so we got maybe 2 minutes. So what else can we say in 2 minutes? So I set up for your email, I set up a JavaScript web page in which you click on the link for the web page and it pops out your email so that spammers won't be able to even find that email.
Okay, that doesn't make any difference. I set up that email. That's dett.tech.
Yeah.
Okay, I set that one up just specifically so when I'm done, I just erase it.
Oh, okay.
That's why I didn't want to use my Wlazlak T because that is my normal email I use, and I don't want to erase that.
All right. What else? So do you want to meet again?
Oh yeah, of course. We'll email a lot, I'm sure.
Okay.
But yeah, we can set up another meeting for a later date.
I could probably do a YouTube. I couldn't do another channel. I don't have, unless we use your phone number to set up a separate channel that's exclusively for your stuff. Otherwise, I would just post it to one of my channels.
Yeah, that's fine too.
Okay.
It doesn't make any difference where it goes. It's just
Okay.
telling people about it, and part of it I want you to be exposed to this too, so people
Well, yeah, to
recognize what
hopefully
you're doing.
understand it. It helps.
Yes, it definitely.
Okay, well, I
Okay,
guess, huh?
off we go.
All right. Thank you.
Okay, I'll email you some drawings and things.
Okay. Thanks.
Okay, I'll talk to you later.
Bye.
Bye.